Women have head circumferences that are normally distributed with a mean of 22.65, standard deviation of 0.8 inches. As always, I encourage you to write that down. Mu is 22.65 and sigma is 0.8 or 0.80. Part A asks, if the Hats by Lico Company produces women's hats so that they fit head circumferences between 21 inches and 25 inches, what percentage of women can fit into these hats? And again, at this point, some of you are drawing the pictures, some of you have this in your head. I will say I think the betweens are the ones that are the easiest because it's a probability 21 is less than your x is less than 25. You don't have to worry about the nines or the negative nines, and because it is inches, just like your mu and your sigma, you know that those numbers were along the horizontal axis, which means we're using normal CDF from 21 to 25. Mu is 22.65 and sigma is 0.8. Now notice our sigma is 0.8 and we're not dividing by the square root of anything because we're only looking for the probability of one person fitting into these hats. There's no group, there's no N, and so we don't have to divide by anything. Put that in your calculator and you should get 0.9788. Keep in mind the problem asks for percentage. So this company can say 97.88% of women will be able to fit into the hats with sizes from 21 inches to 25 inches. However, Part B says if 64 women are randomly selected, what's the probability that their mean head circumference is between 22 and 23? So we've narrowed the size of the hat to between 22 and 23 inches, and we also now have a group along with the reminder that we're finding an average, a mean head circumference. So similar setup, normal CDF from 22 to 23, mu is 22.65, but this time the sigma is 0.8 divided by the group, the square root of 64. And our answer, again, if you want to see that on the graphing calculator, if you're still struggling, I've pulled my calculator up. We have the lower 22 to 23, 22.65, and then we type in 0.8 divided by square root of 64. Hit paste and enter. Our answer then becomes 0.9998. Usually they ask for 4 decimals. And since it's a probability, we leave it like that. Although you can always think about it as 99.98%. That is really, really close to 100%. Part C says if this probability is high, which it is, does it suggest that an order for 64 hats will very likely fit each of the 64 randomly selected women, why or why not? If this company uses this percentage and orders 64 hats and plans on being able to sell all 64 of them to fit these women, is that going to happen? Is it very likely to happen? Well, no. Because the problem with finding an average is that it doesn't reflect, you might have had somebody with a really small head, somebody with a really large head, but they averaged out to this size. So be careful when you're dealing with individuals versus groups. Is it likely that each of the hats would fit? No, because our probability was an average.